In this video, I show you how I build the line following robot from its kit of separate parts, and in a later video we'll adjust and test it. Hi, I'm James Barr from Fun Building Robots, where we bring enjoyment, fun and learning through building autonomous robots. If you are not yet confident with soldering skills, then please hop over to my previous video number 60 in this series, where I give a detailed tutorial on soldering for electronic circuits. So let's get started. Here's the kit of parts. The printed circuit board identifies all the components and their locations, and so that's very helpful. However, the instruction sheet for this kit is printed in Chinese language, which for English speakers is not so helpful. However, I have produced a list of components in English, which is much more helpful. And I'm going to be working from the English list. I've got all the loose components, little small components, in a tray here so that they don't fall off the desk. And the larger components are kept in the bag for later assembly. So we're going to start using the list from the top, and we're going to identify the LM393 chip holder and insert that into the board. The chip holder's got 8 legs, and it has a little notch in one end. Can you see? And that must correspond to the notch in the diagram on the printed circuit board, because that helps that will identify pin number 1 of the chip. So I insert that into the board, flip the board over and bend a couple of the legs on the diagonals so that the chip holder doesn't fall out while I'm soldering it, because I've got to turn the board over while I solder it. So we're going to set off soldering. I've got a nice hot soldering iron. I'm going to clean the bit in my bit cleaner, which is a stainless steel pan scrubber. I also have now a new soldering iron stand. So I'm going to thin the end of the iron and apply that to the pad of that. Pour some solder in and hold it for 1 second, and we're done on each joint. So it's a 3-second rule. It goes on nicely, and the solder resist, which is the blue varnish on top of the board, prevents the solder running across to other connections. Just needs about 1 millimeter of this quite thick solder. That's all done. Next, we're going to insert and solder these 2 capacitors. It's important that they are put in the right way round, because one leg is to be wired to the negative side of the circuit and the other leg is the positive. This is clearly marked on the board and on the component. The negative side component wire also is shorter, so there shouldn't be any mistake about how these get inserted. We're going to put the positive wire in first because it's longer, and then the negative wire, and insert it most of the way in and bend the legs on the other side of the board to stop the component dropping out when we solder. Like that. So double check that we've got the right component in the right hole. It's marked C1 and C2. They're 100 microfarad, so that's suggesting capacitors. And we've got the positive leg down the positive hole. So I think we're okay there. We'll turn it over and support the board a little bit because of ground clearance. We need a bit more. We'll just solder it on the edge here. Right. I think that's okay. You seem to be firmly inside, firmly locked in, so I'm going to trim the excess length of the legs. Sorting out the resistors is slightly problematic, but not really when you've got a multimeter like this. This is a sure way of being sure where, this is a certain way of being sure which resistor you're talking about. So here, these four resistors are reading 51 ohms on the 2K scale. So because it's a 1000 scale, divide by multiply that number on the display by 10 to the 3, so that's 51 ohms, so that's pretty certain. Switching to the 200 range, this reads very low. Let's move it back to there. This is reading about 11 ohms. So those are the 10 ohm resistors, which are resistors number R9 and R10. Similarly, these resistors are reading 3.3 kilo ohms. So those are resistors R3 and R4. And this pair are reading 1 kilo ohm. So these resistors are R7 and R8. So we'll put these into the board and solder them up and show you the result. So here's the board with all the resistors soldered in. So we're making progress. Next are the two light dependent resistors whose resistance value changes with whether there's light shining on them or whether they're in darkness. We'll place those on the board and solder those in. Now the thing is that they need to be at the same kind of height close to the ground as the supporting front leg, so that's why I've installed the front leg into the robot chassis so that we've got the height for the light dependent resistors. Next, we'll install the two indicator LEDs. Now, LEDs have a polarity. There is a slight flat edge on the cathode lead, at the cathode lead here, and the longer lead is the anode. Now, it's important to have these the right way round in the circuit, because LEDs are diodes, which means that current should only flow from the anode to the cathode, and if they're wired in the wrong way round, they will not emit light. On the board you can see the little diagram for a LED, which is here on the corner. It's a triangle pointing to a flat line. The flat line is indicating the cathode, and the other side is the anode. So we'll install these and show you when they're finished. So here the LEDs are installed. The little flat edge here is in line with the flat edge at the tip of the triangle in the diagram on the board. So hopefully that's the right way around. I think it is, and the same on the other side. Here are the two white-bodied LEDs, which I've selected to be the transmitter LEDs for the sensor, and those go on the B side of the board and need to be lined up with the light-dependent resistors. Okay, here's the result. So I've got the installed clear-bodied transmitter LEDs that shine on the black line, and the installed light-dependent resistors which sense the line, the contrast. Here we have the two transistors which send electricity power to the motors. Being transistors, they have three legs, and we will install these. They also have a flat side, and it's important that they go in the right way around according to the board. You can see that the board has a flat side and three holes. So we'll install those next. So here the two transistors are installed with their flat sides lined up with the mask image printed on the board. Master on-off switch next, which has 6 pins at the back. We'll install that next. Okay, that's finished. Master switch in. We're going to install the battery box and connect the red and black wires. Installing the battery box involves peeling off the red plastic film from the double-sided sticky pad and making sure that the wires come up this side of the board to go through that little hole. So here we are. The red wire has been connected to the soldering point marked plus, and the black wire to the other one. Next we're going to install the two motors. This is slightly tricky because it's not clear exactly which way to polarize the motors, but it's a kind of suck it and see method. So here you can see I've trimmed and prepared these two connecting wires for the motors, and I've positioned the motors in the way that they'll be mounted onto the chassis. the important thing is that the motors are actually wound, the motors are actually connected the opposite way to each other. So the red wire ends up on the connection of the motor nearest the board, and the black wire on the top connection in both cases. And because they're mirror images of each other, in fact that means that they're wired opposite to each other. So one motor will go forwards and one motor will go backwards, but that ends up being the right thing because their wheels are on different sides of the chassis. So I'll connect these wires up now and mount the motors, and we'll take it from there. There we are, there's the connections made for that motor and for this one. You can see that the red wire is connected to the motor on the PCB side connection, and the black wire to each motor is on the upper side of the motor. Here are the wheels. We'll connect those next, and we're nearly done then. I'm going to insert the LM393 silicon chip now. It's important to note that it has a notch at one end, which must correspond to the notch in the chip holder and the printed image on the circuit board. When those all line up, then we know that we have pin 1 of the chip inserted into the correct position. So here's the little robot car complete now. We'll give it a final visual look over, make sure everything looks okay, and keep our fingers crossed. Right, I've inserted two not very expensive batteries so that we can test it just in case there's a dead short. So we can switch it on and see what happens. Oh yeah, we get nice light shining on the floor, and it's driving one motor. Next step is to test it over that line. So I've taped the test track to the desk. We're going to switch on and see if we can get it to switch. Oh yeah, it switches between states as it crosses the line. So will it walk round? Yes, it will. Totally working. So I hope you've enjoyed that quite long video showing the construction of the line following robot. By being very careful with soldering technique and following the careful layout of the board with the components, making sure that they're in the right polarity and we had the right resistor values in the right slots, we had a very successful first run. I mean, it was right first time, which is what you hope for, but don't often get. If you've enjoyed this video, please like and subscribe, and we'll follow on with more autonomous robot construction projects. Cheers for now.